exercise 3, determining the moles of atoms. Aluminum is a metal with a high strength to mass ratio and a high resistance to corrosion. Thus, it is often used for structural processes. Let me tell you right now, that has nothing to do with what you have to do. All right. One of the things that really blows me away, as a biology major, a non-chemistry, a non-physical science major, one of the things that really surprises me about the way chemistry questions are worded is how much information that you don't need that they give you. Aluminum is a metal. For this problem, it does not matter. It has a high strength to mass ratio. Doesn't matter. High resistance to corrosion. I don't care. It's often used for structural processes. It could be. I don't care. So let's look at the prompt, right? What are we supposed to do? We're supposed to know stuff. That's what the AP exam is gunning for. Do we know how to do these calculations? So let's make sure we understand what we're being asked to do. Calculate both the number of moles of atoms and, so we're doing two things here. Moles of atoms and the number of atoms in a 10.0 gram sample of aluminum. So we have aluminum. We're using aluminum. How much aluminum are we using? Aluminum. How much are we using? The 10.0 grams. 10.0 grams. Okay, so we are starting with 10.0 grams of aluminum. Now, just real quick, for this particular problem, we don't necessarily have to write the aluminum, but when we are using stoichiometric conversions containing two different substances, right? If we're converting from, maybe using mole ratios to convert from, grams of aluminum to grams of iron, something else, it's going to be very, very useful for us to include the species. If you don't include the species on this specific type of problem, not that big a deal. But you will be leaving yourself open to forgetting what species we're actually talking about. So I suggest making a habit of always writing the species as well. So we have 10.0 grams of aluminum. We need to calculate the number of moles. Well, we have mass in grams, don't we? We need to get to a number of moles. So we're going to use the molar mass in order to do that conversion. The molar mass of what? Aluminum. Da-da-da. Periodic table. 26.98. 26.98. Right? 1535 or 85, whatever. Let's just stick with 26.98. Okay, in my experience in college, it was always 26.98, right? I pretty much don't even have to look at my periodic table. It's 26.98. So I'm going to set up a conversion factor that has grams of aluminum on the denominator and moles of aluminum on the numerator. I know that for every 1 mole of aluminum, there are 26.98 grams of aluminum. Just found that out from looking at my periodic table. So now, after I do my multiplication and division, the grams of aluminum will be gone. I will be in moles of aluminum, which is one of the things I'm supposed to calculate. Right here. Moles of atoms. How many moles? How many moles? So, moles of aluminum. Moles of atoms of aluminum. Set that up. We'll be good to go. So, calculator time. 10.0 divided by 26.98. 0.3706. How many significant figures? Because remember, calculator vomit, all this stuff back here. I want to use 3 sig figs. Why? Because of the 10.0. Right, the 10.0. So I'm going to stop right there at that 0. What does the 0 tell me to do? Or should I say, what does the number right behind the 0 tell me to do? The 6 tells me to round this up. So I am actually going to call this 0. Remember, always write the 0 first. 0.371. 0.371 What's the unit? Moles of aluminum. And isn't that one of my answers? Number of moles of atoms? There are 0.371 moles of aluminum atoms there. So that's half of my problem. Next half, how many atoms are present, right? The number of atoms. Well, if I want to get to number of atoms, I'm talking about number of particles here. So how do I do that? I use Avogadro's number if I have number of moles. Well, don't I have number of moles? Don't I have number of moles? Yes, I do. I have number of moles. So what am I going to do with the number of moles? I'm going to use Avogadro's number to get to the number of atoms. So let's start a new problem down here. 0.371 moles of aluminum. I'm going to set up a conversion factor with moles of aluminum on the denominator for sure, and then atoms of aluminum on the top. I know that for every 1 mole of 1 mole of aluminum, there's 6.022 times 10 to the 23 atoms. Yes. Moles of aluminum cancel. So I still have this in my calculator, so I'll go ahead and just use this. Well, I have the remainder from the problem here. See this? Multiplied by Avogadro's number. So in my calculator, because that's my most recent answer, I can simply press multiply by my stored Avogadro's number, which I have stored it as A, so multiply alpha math button, because the math button, when you press alpha, has that green A you can see. Boom. Hooray for numbers. So it looks like I'm still using 3 significant figures from this that I recorded here, 3 significant figures. So that 3 is going to be the third significant figure. What does the 2 tell me to do? Keep it the same. So 2.23. What are my units? Atoms of aluminum. Oh, totally not. Oh my gosh, I forgot this times 10 to the 23. Holy cow. Oh my gosh, that would have been that would lose you a point right there. That would lose you a point if you had forgotten that. So 2.23 times 10 to the 23rd atoms of aluminum. You might be wondering, if you make an error like this, just like I did, I wrote 2.23 atoms of aluminum and I forgot to write the times 10 to the 23rd, and I'm writing in pen, so I just kind of wrote this up at an angle. This would be okay for a grader. Why? Because I've shown all of my work, all of my calculation, easy enough to read, right? It's not spectacular, but it's easy enough to read, and I've boxed my answer out. And so he's going to look at everything that's in this box in terms of identifying what my answer is. Now remember, there's one thing you got to know about these old folks that are going to be your AP graders. To be perfectly honest, they're rooting for you. They're looking for evidence of you knowing what you're doing. And to the best of my ability, I'm going to grade your quizzes and exams with that same idea. Is there something in your work that shows me you know what you're doing? Even if you get the final answer wrong, was there something present? Because there are plenty of points to be had on the AP exam aside from the final answer. And so this mistake right here, where I added the times 10 to the 23 afterwards, is going to be totally fine as long as it's neat and it's boxed out, because I'm telling the grader that this is my answer. This is my answer.